Section 2.1 is going to go back and review some properties about lines in the plane and slope. So a lot of the stuff that you learned from Algebra 1, however, very important stuff moving forward. You use this all the time in pre-calculus and AP calculus. So there's some details here. Make sure that you go through and you're comfortable with them. So equations of a line, you do need to know the different names. Okay, you do need to know these different names. So general form, notice you have ax plus by plus c equals 0. And in standard form, it's ax plus by equals c. So just notice the differences. Like it says here on the right-hand side, the difference is from other forms is that in general and standard form, a, b, and c must be integers, and a should be positive. Okay, so I think of that as always moving it to where my x term is positive, if you will. All right, and then slope-intercept form of a line, right, just because of the name, slope m, intercept b. And then point-slope form of a line, again, based on the name, point would be x1, y1, and the slope would be m. You guys should know vertical lines are always x equals a number, so like x equals a. Horizontal lines are always y equals, so like y equals b. In the slope-intercept form of a line, like we said, m is your slope, b is your y-intercept. To graph it, you plot your y-intercept first. From there, use your change in y over change in x, or your rise over your run, however you want to think of that, from the slope to get more points. And then as far as slope as a ratio or a rate, okay, if x and y have the same unit of measure, then the slope has no units and it is just a ratio. If x and y have different units of measure, then the slope is a rate or a rate of change. Rate of change is something you will hear all the time in pre-calculus and in AP calculus. Okay, the rate of change. As one thing changes, how fast is the other changing? Okay. You'll see some business problems. So in business problems involving cost, the y-intercept is your fixed cost or your cost of producing 0 units, and your slope is the marginal cost or your cost per unit. So getting into some of the review then, just to make sure that you've got some of the basics down. Your equation for slope, remember m, is your change in your y values over your change in your x values. So remember this notation just says here, this little delta, that means change. So change in y over change in x, that's what's written there. And change in y means just y2 minus y1 over change in x is x2 minus x1. All right, a positive slope, if you will. So let me just go ahead and get us a xy axis quickly for each of these examples, just to make sure that we are on the same page. Let me move this just a little bit. All right, and then just some quick sketches. So a positive slope, remember guys, should go up from left to right. And we're talking about a line, it goes on forever. So I'll just add those arrows. A negative slope should be going down from left to right. A horizontal line should have 0 slope, meaning no rise, right? If you're thinking about rise over run, no rise over the run. So your slope is 0 over some number would always give you 0. And a vertical line, the slope is undefined, okay? Undefined because you would be dividing by 0, okay? Because your rise is, so it's going to look like that. Your rise would be some number over your run is 0. Okay, that's your change in your x's are 0. So vertical lines, undefined, horizontal lines, slope is 0. And then parallel versus perpendicular lines. Remember, 2 lines are parallel if their slopes are completely equal. So m1 slope 1 equals m2 slope 2. And 2 non-vertical lines are perpendicular if and only if, that's what that means again, if their slopes are opposite and reciprocals. So meaning the opposite sign, and if this was over 1, then they are reciprocals of each other. Okay, so let's talk about some of the types of problems that you could see that come up with these types of problems, okay, with this kind of information. So determine if line L1 and L2 passing through, so if lines L1 and L2 passing through the given points are parallel, perpendicular, or neither. So we can't just look at them, guys. You know we've got to show some sort of work. So what I would be doing is the following. I would be saying M, so the slope sub L1, meaning the slope of line 1, equals the change in y. So I'm going to say 5. Notice these are my two y values, right? The 5 and the -1. It's up to me how I want to start. But if I start with the 5 minus -1, remember from Algebra 1, you have no choice now but to start with this 1. So since you chose the 5 first, to make it positive was my thinking. Now you've got to choose the 1 first for the x's. So now it's got to be 1 minus -2. All right, so that's going to give us what? 6/3. So 2, okay, is our slope. And then our slope for line 2 would be 3 minus -5, if I'm just randomly picking a y. But again, since I picked this y first, then I have to pick this x first. Okay, so 3 minus -5, and then the x's would be 1 minus 5. All right, so it looks like I'm going to get 8 over -4 or -2. And remember, if they were exactly the same number, they'd be parallel. If they were opposite and reciprocals, they'd be perpendicular. Well, they are opposite, but reciprocals would mean one would have to be like a 2 and one would have to be a -1/2. And so right there, you're proving that these lines are neither parallel or perpendicular. Okay, so that's what I would be saying there. Number 2, find the equation of the line passing through the given points. Okay, so we're given those 2 points, and then use point slope form to find the equation, and then write your answer in slope intercept form. Okay, so let's talk about this. Even if we did not tell you to use point slope form, guys, this is really the format of what you should do. And some people do this a little bit differently. You're going to find this is going to be your most direct and easiest way to keep you from getting stuck. So remember, these are like x1. Actually, I'll make it this. So this is like your x1, y1 ordered pair, and this would be your x2, y2 ordered pair. Okay. All right, so you're going to find slope always first. So remember, if you're given 2 points, slope is your change in your y values over your change in your x values, or rise over run. So I'm going to go with 6 minus 5, y2 minus y1, over 3 minus 1 to give us 1/2. And then this is the format I'm always going through. Okay, but this is point slope form. So y minus y1 equals slope times x minus x1. Okay. All right, so we're saying that this would be, now let's do this a little color coding here. Let's say I would go ahead and use this point here, the 1, 5, all right, for my x1 and y1. Then I'm going to have y minus 5 equals a slope of 1/2 times x minus 1. Okay, that's point slope form, meaning you can read the slope off of it as 1/2, and you should be able to read the point off of it as 1, 5. That's big for AP Calculus, okay? But then we want to be able to manipulate that, so into other forms. We will ask you to go with all the different forms that we've taught you today, or reviewed with you, I should say. But this one does ask us specifically to write it in slope intercept form. Okay, that means I'm going to go ahead and distribute my 1/2 to get 1/2 x minus 1/2. And then I will combine like terms. So combine like terms by moving the 5 to the other side. Okay, so I'll have 1/2 x, and 5 is 10 halves minus 1 half is 9 halves. Okay, and that's the format you should be comfortable with. Okay, now just in case you're wondering, let's go ahead and do it. What if I had used this point? Okay, you might be wondering, well, is that going to give me something different? All right, well, that form would be then y minus 6 equals still the slope of 1/2 times x minus 3. Okay, so just to prove to you that it's going to work the same, let's go ahead and distribute the 1/2 to get 1/2 x minus 3 halves. And then if we combine like terms, moving the 6 over, we would have y equals 1/2 x. And 6 is 12 halves minus 3 halves would be, once again, plus 9 halves. Okay, so yes, indeed, doesn't matter which point you use, you will end up with that same equation. All right, and then one other type, let's say find the equation of the line. Remember, you should know this symbol is perpendicular, okay, to 2x minus 3y equals 6, and passing through the point 4, 1. So first of all, you should recognize 2x minus 3y equaling 6 as a line, right? It's linear because x and y are both to the first. So I'm going to manipulate that line. I want to go ahead and solve for y. Okay, so if you will, it's kind of like I'm making it 2x minus 6 equals 3y. Manipulating, but I'm just going to put the y on the left-hand side. So if 3y equals 2x minus 6, and I divide everything by 3, I have y equals 2/3 x minus 2. All right, so what I'm getting off of there is that the slope of the line that was given to us, this one, right, that slope was 2/3. Well, we said we want to find the equation of a line that is perpendicular to that. So kind of my notation I'm using is, I'm going to say I want my perpendicular slope then to be opposite and reciprocal. So I want it to be negative 3 halves. Okay, and I'm going to go through the point 4, 1. So anytime somebody gives me a point and a slope, that is all I need to go. Okay, that's exactly what we just did in that last problem. Okay, so as long as I've got a point and a slope, again, I'm going to start out with my point slope form. Y minus y1 equals m times x minus x sub 1. And here we go. So y minus 1 equals our slope of negative 3 halves times x minus 4. And I just want to practice with you. Let's pretend that I asked you to give this to me in point slope form. Well, at that point then, you are finished. Okay, that is point slope form. All right, what if I asked you for slope intercept form? Slope intercept form. That means continue with what we have written in the blue and manipulate by distributing the negative 3 halves. So negative 3 halves x, and negative 3 halves times negative 4 would be 12 halves, so 6. And move the 1 over and combine like terms. So we'll have negative 3 halves x plus 7. All right, that is now slope intercept form. Of a line. Okay. And last but not least, if they now ask us to manipulate this into standard or general form, I'm going to go with standard form. Okay, first. So standard form says we have to have integers, all right? So no fractions. That means I'm just going to take the form that I have, the slope intercept form in red, and I'm going to clear the fractions, right? The only denominator I see is 2. So if I multiply everything by 2, I would have 2y equals negative 3x plus 14. And then, so that's the first thing to know, is that there's no fractions. You got to have integer coefficients. And then we said x and y need to be on the same side, and the x term needs to be positive. So you manipulate it that way, would give me a positive 3x plus 2y equals 14. Okay. Now these are the three forms. Again, this one's standard form. These are the three forms that are the most widely used. In calculus, if I asked for general form just to practice it, that just says it's equal to 0, so you would just take that standard form and move that 14 over. Okay, so it said negative 14 equals 0. 3x plus 2y minus 14 equals 0. Okay, but these are the three that we're going to focus on. And in homework, I will sometimes ask you all three forms. If I say all three forms, that's what I'm asking for. Okay, all right, good luck.